Hello my lovelies, it's Susanna, and today I want to show you how to solve this problem that was part of a math competition in 10th grade. We have this figure here, and we have to find the length of this side. We are given the length of this side, of this part here, and of this part here. And they tell us that we have a right angle here and another one here. And this is all the information we have to find the length of this side. Maybe we call the length of this side x, and x is part of this triangle here. And in this triangle, we know the length of this side, and we know the length of this side, so could we just use the Pythagorean theorem to find the length of this side? No, we are not allowed to use the Pythagorean theorem here because this is not a right triangle. So it's not so easy to find the length of x, but down here we have a right angle, and so we have a right triangle here, and we know the length of this side, we know the length of this side, so maybe we start here and find the length of the third side using the Pythagorean theorem. Okay, let's do that. I call the length of this side y, and for the Pythagorean theorem, we first have to know where the hypotenuse is. That is always the side that lies across the right angle, so this is the hypotenuse. And the Pythagorean theorem then says, take one of your sides, the y, and square it, plus take the length of the other side and square it, so 5 squared, and then you get the hypotenuse squared, so 13 squared. Now we can solve this equation for y. If we calculate this first, 5 squared equals 25, and 13 squared equals 169. And to solve for y, maybe we first get rid of the 25 here. So let's subtract 25 on both sides of the equation. Then we have y squared on the left side. This cancels out. And on the right side, if we subtract that, we get 144. To solve for y, we just have to get rid of the square here. We can do that by taking the square root on both sides of the equation. It's just important to remember that every time you take the square root in an equation, you get two solutions. For our y, we get a first positive solution, and then we get a second negative solution. The positive one is the square root of 144, which equals 12, and the negative one is negative 12 then. The problem here is we are not interested in a negative solution because our y is the length of a side, and this has to be positive, so y is of length 12. Okay, so we know now the length of this side here, and on the other side here, we also have a right triangle. We know the length of this side and of this side, so we can use the Pythagorean theorem again to find the length of this third side. I call it z, and we do the exact same thing. First, finding the hypotenuse across the right angle, and then the Pythagorean theorem says take one of the sides, so z squared, plus take the other side and square it, 12 squared, and this equals the hypotenuse squared, so 20 squared. To solve for z, we first calculate 12 squared equals 144. We just had that. 20 squared equals 400. To solve for z, we get rid of the 144, so let's subtract it on both sides of the equation, so that we have z squared here, because this cancels out on the other side. If we subtract, we get 256. We take the square root again to get rid of the square on both sides. We now know, okay, I get two solutions, a positive one and a negative one. The square root of 256 is 16, and here also the negative 16, but we know we won't use this. We just take the 16 here. Okay, how does this information help us now that we know the length of this side and the length of this side? Because we have a right angle here and another one here, we know that this side here is parallel to this side. And the distance between these two parallel green sides is 5 plus 12, so 17. And this distance, let's make the distance here orange, is the same here as it is up here. So here I could draw a line where we have another right angle here, and I know that this line is of length 17. Now my x is part of a right triangle. Do I also know the length of this side here? Yes, I can't find it because I know the length of the entire side, 16, and I know the length of this part here, 12. So I know that 16 minus 12, which is 4, is the length of this part here. And now we can use the Pythagorean theorem in this right triangle here to find the length of x. For this, we first have to find the hypotenuse again across our right angle. I used the color green already, I used the color orange here already, so maybe let's highlight the hypotenuse in blue this time. And the Pythagorean theorem then says, take one of the sides, so the 17, and square it, plus the other side and square it, and then you get the hypotenuse squared. And let's solve for x now. Let's calculate here first. 17 squared equals 289. 4 squared equals 16. If we add these two numbers, we get 305, which is our x squared. To solve for x, one last time, we take the square root on both sides of the equation. So for our x, we get a first positive solution and a second negative solution again. The square root of 305 is not so easy to calculate in your head, so we just take this as the exact solution here, the negative square root of 305 as well, but we know we won't use u. This is our result, and if you want to calculate it with a calculator, we get a result of 17.46, and we solved this problem. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!